All right, let's get right into it. We're going way, way back, 375 million years to be exact, to explore one of the most incredible stories in the history of life. We're talking about the moment our ancient ancestors took their very first steps out of the water and onto solid ground. This is a huge chapter in our own evolutionary story. But that immediately brings up a massive question, right? I mean, how on earth do you get from a fin, something that's built for paddling through water, to a limb, something that can actually hold up a body and walk on land? For a very long time, this was a giant gaping hole in the fossil record. And this visual just lays out the puzzle perfectly. Over on the left, you see the pretty simple fan-like bones of a lobefin fish. And on the right, the incredibly complex structure of a land animal's hand, with a wrist, a palm, all those little digits. The gap between those two seems just immense. For decades, paleontologists were on the hunt for the creature that could bridge that gap. But this isn't a story about some lucky accident. This is a real-life scientific detective story, a deliberate, calculated hunt for a very specific missing link. See, these scientists weren't just digging around randomly, hoping for the best. They were on a mission. They knew what they were looking for. A transitional fossil, something that was part fish, part tetrapod. A fishapod, if you will. The hunt was officially on. And what's so amazing is how they did it. It wasn't guesswork, they literally started with a map. Paleontologists used everything they knew about geology and evolution to predict exactly where to look. They zeroed in on rock layers that were the perfect age, about 375 million years old, and from the perfect ancient environment. Not the deep ocean, but shallow, freshwater streams. That's where this transition was most likely to have happened. And that search led them here, to one of the most remote, desolate places on the planet, Ellesmere Island in the Canadian Arctic. It took them years of absolutely grueling expeditions in this frozen landscape. But their prediction, their scientific bet, totally paid off. In 2004, they found it. And they gave their incredible discovery a name, Tiktaalik. It was a name suggested by the local Inuit elders, and it's just perfect. It means a large, shallow water fish, which is exactly what this creature was. So what was it that made Tiktaalik so incredibly special? Let's dig into the evidence and see how this one animal was the perfect blend of a fish and a land dweller, beautifully blurring the lines between two completely different worlds. And first off, get any image of a tiny little creature out of your head. Tiktaalik was a serious predator. It could grow up to 9 feet long. With a big, flat, almost crocodile-like head and a powerful body, this thing was a major player in its ecosystem, not some timid little experiment hiding in the weeds. Its whole body was just this amazing mosaic. It absolutely still had fish-like features. Gills, scales, fins, but it also had features that were just shockingly new. It had a flat skull with its eyes on top, kind of like a croc. It had a mobile neck that could turn side to side, independent of its body, something no fish can do. And it had a super robust, overlapping rib cage, probably to help support its body against gravity. But the real bombshell, the discovery that changed everything, was what they found inside its front fins. When the scientists looked at the bones, they saw a pattern they immediately recognized. There was one big bone, connected to 2 smaller bones, connected to a little cluster of wrist-like bones. This wasn't just a fin anymore. This was a proto-limb. It had a shoulder, an elbow, and a primitive, flexible wrist. So, what does all that mean? It meant Tiktaalik could do something no ordinary fish could even dream of. It could bend its fin at the elbow and the wrist, plant it on the riverbed, and basically do a push-up. This was the critical motion that let it prop its body up in the shallows, or maybe even on a mudflat. It was the very first step towards walking. Okay, so now we know how it could start to move onto land. But that leads to the next big question. Why? What was the motivation? To figure that out, we need to look at the world Tiktaalik lived in and understand the evolutionary pressures that were literally pushing life ashore. So Tiktaalik lived during a time called the Late Devonian period, which was a time of massive environmental change. And crucially, its existence right around 375 million years ago lines up perfectly with a big spike in the Earth's atmospheric oxygen. And that's no coincidence. It was a catalyst for change. And you have to completely reimagine the Canadian Arctic. Forget ice and snow. 375 million years ago, that landmass was sitting right on the equator. It was a warm, subtropical world filled with shallow, winding rivers and swamps. Think of something like the Amazon River Delta today. It was the perfect laboratory for evolution to work its magic. This environment was absolutely teeming with opportunity, but also with danger. You had rising oxygen levels fueling more and more life, but that also meant more competition and bigger, scarier predators in the water. For a creature like Tiktaalik, the shallows, and maybe even the land itself offered a potential escape route and a whole new untapped menu of food, like insects and other arthropods. So we've got the creature, we've got the anatomy, and we've got the motive. And now for the final incredible payoff. Because this isn't just a story about some ancient fish. This is the story of our own bodies. And here it is. This is that aha moment. The puzzle is solved when you see them side by side. That bone pattern in Tiktaalik's fin, one bone, then two bones, then the little blobby bones, it's the exact same blueprint we see in our own arms. One bone, the humerus. Two bones, the radius and ulna, and the little blobs that would become our wrist and hand bones. It is literally our arm in its earliest, most primitive form. Just think about that for a second. Every time you pick something up, wave to a friend, or type on a keyboard, you are using a set of joints, a shoulder, an elbow, a wrist, that first evolved in a fish that was learning how to do a push-up in some shallow stream hundreds of millions of years ago. The architecture of your arm started right there, with Tiktaalik. Of course, you can always count on the internet to have a, let's say, slightly less profound take on this amazing evolutionary leap. This popular Reddit comment kind of perfectly captures the funny, relatable downside of leaving the water for a life of jobs and rent. You gotta admit, it's pretty funny. In the end, Tiktaalik is just this profound reminder that our bodies are living history books. We carry the legacy of these ancient worlds and these pioneers that took the first wobbly steps into a whole new frontier. It solved one of evolution's greatest mysteries, and in the process, it gave us our arms and hands. It just makes you wonder, what's the next chapter for us? What are we evolving into right now?